Hello dear students, today I am going to discuss about the continuity of a function in a closed interval AB. Okay, when the function is defined in a closed interval AB, how to check the continuity of that particular function in this closed interval. Okay, that is the discussion of today's class, and I will solve a question related to this particular concept. Okay, so your function is f is a function f is a function defined in a closed interval AB, and which is a real value, means its range will be subset of R or maybe set of real number. Okay, so it is a real value function. उसका जो value होगा, suppose this is x, इसका image क्या होगा, fx होगा, and fx is a real number and therefore it is a real value function. Now f is continuous in this closed interval means the f is continuous at a, f is continuous at b, and f is continuous in open interval AB. If you draw the interval, you see this is your A end point and this is the right end point. Okay, this is the left end point, this is the right end point. The function will be continuous in this closed interval if it is continuous at A, continuous at B, and continuous within what, A and B. So at A one point, another point B, another is what, open interval AB. Okay, so there are three cases. In these three cases the function is continuous, then you can conclude that the function is a continuous function whose domain is the closed interval AB. Now very interesting is that when it is continuous at A and when it is continuous at B. Understood? So you already know that a function is continuous at a particular point. Suppose if I say, suppose A is a point in a domain of the function is continuous at A means limit, left hand limit is equal to okay, this is the definition. Okay, you know that a function is continuous at a particular point if left hand limit is equal to right hand limit is equal to what, functional value. Okay, and when you get left hand limit when x is approaches to a from left, and when you get right hand limit when x is approaches to a from the right. But here very interesting thing is that since this is your point, okay, so there are many x can be approaches from right, there is a possibilities, so you are getting a right hand limit. Okay, but since there is nothing left of a, because it is the end point, there is nothing in the left of a, and so there is no possibilities of x tends to a from the left, because a के पीछे इधर left में कोई number नहीं है, so there is no possibilities of x tends to a from what, left, and therefore there is no possibility of left hand limit. Okay, so to check the continuity at a, since left hand limit का सवाल नहीं, तो हमारा क्या होगा, only right hand limit which is equal to functional value. That means what happen, ये जो part है, ये part इसमें ज़रूरी नहीं है. Okay, it is sufficient to show that this is equal to right hand limit is equal to what, functional value. So f is continuous at a means mathematically we can write limit x tends to a plus fx equal to what, fa. Okay, if you show this, then it is sufficient. Similarly for the point B, it is also a particular point, but x is approaches to B from left is possible, but there is no x, no real number right of B, there is no possibilities, and therefore right hand limit there is no question of right hand limit का कोई question नहीं होगा. Understood? And since x is approaches to B, there is no possibilities and there is no question for right hand limit, and that is if you want to show that the function is continuous at B and which is the right end point of the closed interval, then it is sufficient to show that limit x tends to B minus fx equal to what, fb, means only you are getting what, left hand limit. Since x is approaches to B from left, so you are getting left hand limit and which is equal to functional value, there will be no right hand limit. I hope you understand this particular content. Okay, so the function f is continuous in AB, closed interval AB, means what, that it is continuous at A means right hand limit is equal to functional value, and it is continuous at right hand point means left hand limit is equal to functional value, and it is continuous in all the points between what, A and B. which means all the point inside the open interval. Open interval में कि सारे point में continuous होगा. अगर यहाँ में एक point लिया जाए यहाँ every point you see you can get x is approaches to this point from left, from right, from left, from right. So सारे point में आप left hand limit, right hand limit rule use कर सकते if particular points are given in between. अगर नहीं दिया जाएगा तो कंडीशन दिया जाएगा, उस समय जनरल केस जैसे डिस्कस करते हैं उस ऐसा हम प्रॉब्लम सॉल्व कर सकते हैं. सो with this concept I am going to solve one particular question and I hope your conception will be more clear. Okay, this is the question. You see, you have to discuss the continuity of the function. The question का heading क्या होगा? Discuss the continuity of the function. Okay, discuss the continuity of the function means you have to discuss at each and every points in its domain. First, your target is to find what is the domain of the function. What is the domain of the function? You see, if you draw the number line, you will observe. So this is your 0. Starting by what? 0. End point क्या है? This is 0. X greater than equal than 0. 0 से शुरू हुआ. Then it is up to 1. Okay, this is up to 1. Okay. Then again greater than 1 and less than 3. Means between 1 and 3. Between 1 and 3. And then again x equal to 3 and end by 6. X equal to 3 and end by what? 6. So ultimately your domain is 0 to 6. Since there is a symbol equality is there and there is a symbol equality is there, so this is closed. This is what? Closed. So finally your domain is the set of domain is the closed interval 0 to 6. So your solution में शुरुआत कैसे होगा? Clearly, domain of the function is the closed interval 0 to 6. Now, you are going to discuss the continuity of the function in this closed interval. So, in this closed interval में आपका क्या क्या points दिया गया है? 0 point and 6 and 1 and 3. Okay, there are 4 particular points, and at the same time, there are many points between 0 and 1. So this is one general case. This is another general case. This is another general case. Okay. This general case you can write 0 less than x less than 1. That means between 0 and 1, excluding 0 and 1, all the points are here. And from between 1 and 3, this is 1 less than x less than 3. And between 3 and 6, 3 less than x less than 6. So there are 3 general cases. And particular cases are what? 0, 1, 3, 6. That means how many cases? Case number 1, 2, 3, 4, 5, 6, 7. 7 cases you have to discuss. And finally conclude that whether the function is continuous or not. That is our requirement of the question. Okay. So first we will discuss about the general case. Okay. First condition, case number 1. Case 1. When 0 less than x less than 1 means we are considering the point between 0 and 1, not excluding 0 and excluding 1. Within this interval, if you see x equal to 0, when x equal to 0, f0 equal to minus 1, when x is equal to 1, f0 equal to minus 1, and between 0 and, that means when 0 less than x less than 1, yes, जो interval होगा 0 less than x less than 1, इस इंटरवल में भी fx का वैल्यू क्या है? -1 है. So when 0 less than x less than 1, fx equal to what? -1. And you know that this is a constant function, is a constant function. Okay, is a constant function, and we know that constant function are always continuous. Therefore f is continuous for 0 less than x less than 1. That means whatever be the point between 0 and 1, for every point the function is continuous. Function is what? Continuous. So first case we discuss. Now case 2. Case 2 में क्या होगा? This is the case, 1 less than x less than 3. When 1 less than x less than 3, you go to this condition, your function is what? 4. Fx equal to what? 4. Now fx is equal to 4 is a constant function, same concept to be written, same language to be right. So here you can say fx is equal to minus 1 is a constant function. You have to write as fx is equal to 4 is a constant function, and therefore f is continuous for 1 less than x less than 3. ठीक है, ये लिख सकते हैं आप same type of. Now case 3 में क्या हो रहा है? When the last case, general case 3 less than x less than 6, this case is included here. Okay, and for this functional value is equal to what? 2. fx is equal to what? 2. And this particular function is again a constant function, and hence f is continuous for 3 less than x less than c. So same pattern of language you have to write and express your answer. Okay, so all the general cases I have discussed, and now I am going to discuss about particular cases. There are 4 particular cases. These are the main important discussion of today's class. Okay, now among these 4 points, 2 points are the end point of the closed interval. 2 points are what? End point of the closed interval. And I already discussed about how to show that a function is continuous at the end point of a closed interval. Okay, let us discuss at x equal to 0, left end point. At x equal to 0. At x is equal to 0, you see already I told you that since there is no x available, so there should not be any question of left hand limit. So you just start with right hand limit. Right hand limit is equal to limit x tends to 0 plus fx. Now you already know x tends to 0 plus means x is approaches to 0 from right, means x is greater than 0, and x is greater than 0 condition is included here. X is greater than 0, and for this functional value is equal to what? Minus 1. So you can write limit x tends to 0 plus fx is replaced by what? Minus 1. And we know that limiting value of minus constant means it is a constant quantity because it is independent of x, and therefore there will be no change, it will be minus 1. Now you are checking the continuity at x equal to 0. So at x equal to 0, what is the functional value? Means what is f0? When x equal to 0, you see conditions, when x equal to 0, you write f0 here. f0 equal to what? Minus 1. So you can write it is f0. Okay, so left hand limit, right hand limit is equal to what? f0. So this is the condition that a function is continuous at the left end point of the closed interval. So you can conclude that f is continuous at x equal to what? 0. Similarly, another point at x equal to what? 6, right end point. हम end point खत्म करें पहले. At x equal to 6. At x equal to 6 क्या होगा? You are going to find there is x is tends to 6 from left. There is no possibility of x. So right hand limit, there will be no question of right hand limit. So start with what? Left hand limit. Left hand limit is equal to limit x tends to what? Which point? At 6. So 6 minus fx. Okay. Now x tends to 6 minus means x is less than 6, and x is less than 6 is condition is included here. So functional value is what? Function का जो replace करेंगे, क्या replace करेंगे? It will be replaced by 2. So limit x tends to what? 6 minus fx is equal to what? 2. And we know that limiting value of a constant is equal to what? Constant. And this 2 is also, you have to check the right left hand limit is equal to functional value. तो functional value क्या है? f6. f6 क्या है? देखो, when x equal to 6, f6 is equal to also 2. So this 2 can be written as f6. So this satisfies the condition of left hand limit is equal to functional value at the right hand point, and therefore you can conclude that the function is continuous at x equal to 6. Therefore you can write f is continuous at x equal to what? 6. Okay. Now we are going to check another 2 points, that is 1 and 3. And in the point 1 you see it is x tends to 1 from left, x tends to 1 from right. So you are getting left hand limit, right hand limit and functional value. And here also x is equal to 3, tends to 3 from left, x tends to 3 from the right. So again you are going to check it is by the definition left hand limit is equal to right hand limit is equal to functional value. If these three conditions are satisfied, all are equal, then you can say that the function is continuous at these points. Now let us check the 1.1. I am going to check one and you will check other one also. So at x is equal to 1. At x is equal to 1 में हम चेक करेंगे, ठीक है. So first you find left hand limit. Left hand limit is equal to what? Limit x tends to 1 minus fx. Now x tends to 1 minus is means x is less than 1. When x is less than 1 condition is included in this part. x less than 1 होने से fx क्या होगा? -1 होगा. तो आप लिखेंगे limit x tends to what? 1 minus -1 एंड इसका लिमिटिंग वैल्यू क्या होगा? -1 होगा, ठीक है. राइट हैंड लिमिट निकालो. राइट हैंड लिमिट क्या होगा? लिमिट x टेंड्स टू व्हाट? 1 प्लस fx. ओके, एंड x टेंड्स टू 1 प्लस मीन्स यू नो x is greater than 1. x is approaches to 1 from right, so x is greater than 1, and x greater than 1 condition is included here, and you can write fx is replaced by what? 4. So you can write limit x tends to 1 plus 4, and limiting value of 4 is equal to what? 4. Okay. Now you observe that is left hand limit and right hand limit are equal. If they are equal, then you can move for functional value. आप functional value निकालेंगे. अगर equal नहीं है तो वहाँ ख़त्म कर सकते हैं कि function is discontinuous. तो आप observe that -1 is not equal to 4. Therefore left hand limit is not equal to what? Right hand limit. अगर ये unequal हो तो function तो discontinuous ही है, तो आप फंक्शनल वैल्यू में जाने का ज़रूरत नहीं. अगर इक्वल हो जाए तो फंक्शनल वैल्यू चेक कीजिए और देखिए तीनों इक्वल हुआ कि नहीं. सिंस लेफ्ट हैंड लिमिट इज नॉट इक्वल टू राइट हैंड लिमिट, देयरफॉर f इज discontinuous at x is equal to what? 1. Similarly you can prove that. Similarly in this point you can check लेफ्ट हैंड लिमिट निकालो और राइट हैंड लिमिट निकालो. देखो दोनों में क्या होगा? अनइक्वल होगा. लेफ्ट हैंड लिमिट इज इक्वल नॉट इक्वल टू राइट हैंड लिमिट होगा. एंड फाइनली यू कैन कंक्लूड दैट द फंक्शन इज discontinuous at x equal to 3 also. So after discussing throughout this domain क्या था? Close interval 0 to 6. We get 2 point 1 and 3 where the function is discontinuous, and all other points within this general cases the function is continuous, and particular case endpoint 0 and 6 the function is continuous. Okay, only 2 points the function is discontinuous, and since the function is discontinuous at 2 points, so definitely it is a discontinuous function. And what are the point of discontinuity? The point of discontinuity are 1 and 3. Finally you conclude that the point of discontinuity of the function are 1 and 3. Okay, hope that you understand this question and how we apply the concept we have discussed about the continuity of a function in a closed interval, and this is the particular question. Similar type of question are there in your textbook, you see, and you try to solve this particular question. Okay, I mean question number 14 ऐसा कुछ होगा, आप ट्राई कीजिएगा सेम टाइप ऑफ क्वेश्चन एंड यू कैन एबल टू डू इट. ओके, वन आपका प्रैक्टिस भी हो जाएगा और कॉन्फिडेंस भी बढ़ जाएगा. ओके, थैंक यू वेरी मच एंड हैव ए गुड डे है.